Hello, today we're going to look at discrete and continuous random variables. Now, a random variable is a variable whose value is a numerical outcome of a random phenomenon. So whenever there's anything that's random that pops up, we can make a distribution, and that x will be the random variable. Now, it's a discrete random variable if x has an accountable number of possible values. And then we can make a probability distribution of that discrete random variable x with the probabilities. And this is kind of more abstract. And the next slide, it'll be more concrete. So for instance, here we have a random variable x. It tells us the grading distribution for North Carolina State University. It's either 0, 1, 2, 3, or 4. And then we have a probability distribution which displays the probabilities below. Now, x is a random variable because these numbers happen at different values. And if you pick something at random, we're not entirely sure what that one would be. But we can find probabilities based on it. What's the probability our random variable will be bigger than 2? Well, that would just leave us a 3 and a 4. So I'll have to add 0.43 plus 0.21 to get a total of 0.64. So, and this is discrete because they're just 0 through 4. There's no values in between there. Now, discrete and continuous. A continuous random variable, there's an infinite amount of answers. So if I say, what is the height of a person? This person could be 6.1 feet. Or we could say we can measure closely. We can measure closely and see that they're 6.123 feet. Or we could see that there's 6.12385 feet. So the closer and closer you measure, the more and more exact you can be. So there's an infinite amount of heights that people can be. And so we call that a continuous random variable. A discrete random variable, it's clear there's a countable number of things, 0, 1, 2, 3, or 4. That's discrete. Now when we're dealing with continuous random variables, it's hard to pinpoint one thing exactly. So we usually have some idealized curve, like a density curve. Now a continuous random variable takes all the values in an interval of numbers. The probability distribution x is centered by a density curve. Now this is an example. The area here represents the probability of that event occurring. Now each individual outcome has a probability of 0. This kind of drives some people nuts, but the probability of anything exactly happening in a continuous random variable is 0. But there's probabilities between things. For instance here, the probability that I'll spin the spinner, that goes from between 0 and 1, and it will go between 0.3 and 0.7. 0.3 is somewhere out here, 0.7 is somewhere out here. So we want to find what is the probability it gets in here. Well, since we go from 0 to 1, this is 0.4 in between here. It's 0.4 over 1, which is just 0.4. All right, now try, you're on your own.